Hi, in this video we will be discussing GMAT Official Guide 2017 edition Quant Problem Solving question number 42. Let's have a look at this question. The question says the positive two-digit integers x and y have the same digits but in reverse order. Which of the following must be a factor of x plus y? So this is a must be question. So as we know that for a must be or a could be question, plugging in is the best way to solve it. Right, so for this question again we will do the plugging in first, but probably later part we will discuss what is the math behind it. So let's see what is the plugging in way of solving this question. So they have given us two positive integers x and y. So let's plug for x and y some two positive integers, but they have the same digits but in reverse order. Say for an example, if you have x as say 21, right, y would be 12, right. Otherwise if you take x as some 32, then y would be 23. Same digits but in reverse order. Since it's a two-digit number, you will have a tens place as well as the units place. Alright, the question is asking you which of the following must be a factor of x plus y. So let's take this first example. So x plus y would be here, what, 21 plus 12 would be 33. Okay, so which of the following, right, must be divisible, must be a factor, that is 33 is divisible by which of these following answer choices? So definitely 6 does not divide 33. Right, so you can eliminate A. 33 is not divisible by 9, so you can eliminate 9. 10 of course not, can eliminate. 11 3s are 33, hold on. 14 definitely not. So we can pick the answer choice as D and we can move on. So you can think about, is it really that we need to try another set of values? No, not necessary. If for one set of values, if this does not hold, then we can eliminate that answer choice, because this is a must be question. Remember that must be means for all the set of values. Which of the following must be means always, right? So always a factor of x plus y. X plus y always means for one set value of 6, 9, 10, 14 does not divide, then 11 is only dividing, then 11 has to be the only answer choice which is going to match the condition here. That match the condition is in the sense factor of x plus y. Okay, so here the answer is D, 11. Now let's see what is the math or theory behind this question, right? So they have given us the positive two integers x and y have the same digits. Okay, so let's call some x as some, right, a into b, right? So a two-digit number will have a tens place as well as a units place. So let's call the units place here as b and tens place here as a. Then y will have the same digits but in the reverse order. So in that case, right, now y will have b as a tens place and a as the units place. Okay, which of the following must be a factor of x plus y? Remember that any two-digit number can be expressed as, right, 10a plus b. That is, for an example here, since you have a tens place, you can write this algebraically as 10a plus b, and this we can write it as 10b plus a. So if you look at it, the question asks which of the following must be a factor of x plus y. So if we add this up, you will have is 11a, 10a and a here, so 11a plus 11b. So 11a plus 11b means then 11 into a plus b would be the, the product, right? So that means 11 into a plus b means it's a multiple of 11. So of course then it will be 11 would be a factor of x plus y. So in that case, can we generalize that always any two-digit integers, if added in such a way that one is the one is the inverse, one is the reverse of other, and if we add each other, then always it could be a, always it will be a multiple of 11. So yes, we can conclude that. Just remember that any two-digit integers, if for an example 24 and 42, if you add it, 24 the reverse is 42, always that will be divisible by 11. Okay, so this is the theory behind it. So what else we can take away from this question? Just remember that it's not only for addition, for subtraction you would find that it is always divisible by 9. So let's take the same case here, 10ab, 10ba. Suppose if you are finding x minus y, right? Suppose if you are finding x minus y, then we will have is 10a subtracted a, then you will have is 9a minus 9b. So that means 9 into a minus b. So that means it's a multiple of a 9. So that means when we are subtracting two-digit integers where they are reverse of each other, that is, tens place is, for one's tens place, the others it is units place. Likewise, vice versa, right? Likewise, for one's tens place, the others has to be the ones place, that is units place. So if at all in that order, then if you are subtracting these two digits, then always it will be a multiple of 9. So let's take an example here, right? 36 if we take the inverse, it will be 63. So if you find the difference here, so it will be what, 7 and 2, so 27. So 27 is of course divisible by 9. So let's take the same now, the numbers which you already took, 24 and 42. 24 and 42 difference is 18, so that means it will be divisible by 9. So generally any two digit integers, if they are matching the condition, that is matching this condition that they are reverse of each other, then always addition will be divisible by 11. Sum of these two integers will be divisible by 11 and difference of these two integers will be divisible by 9. Okay, so here the answer has to be D because they are asking for sum. So this is a good part or good thing about your GMAT. You will learn from the questions, the theory. So always is the best way to learn when it comes to an aptitude exam, right? So you learn from the question. This way it helps you to recollect things. But if you learn theory and then you go about solving question, then you will try to always map to the theory into the question, which may not be a good idea. Always learn from the question. This will help you to suppose at some point some question comes in the same way, you can just recollect it because you have learnt it, because you have solved from the question. Alright, I hope this is clear. Thank you.